This is section 12.6, adding and subtracting rational expressions. If you'll remember, to add and subtract fractions, you have to have the same denominator in each term. So, of course, the basic form here is a divided by c plus b divided by c. In this case, they're the same denominator, so you just add the numerators. So you end up with a plus b divided by c. In our example with the same denominators with numbers, we have 5 divided by 3x plus 7 over 3x. Because the denominators are the same, you just combine the numerators. So you end up with 12 divided by 3x. This can be simplified because you have common factors of 3 in both the numerator and the denominator. So you end up with 4 divided by x. In the next example, 3x divided by x plus 1 minus x plus 5 divided by x plus 1. Again, you have the same denominator here. So you're just going to subtract the numerators. So you end up with 3x minus the quantity x plus 5, all divided by x plus 1. You need to simplify and combine terms in that numerator so that you get 2x minus 5 all over x plus 1. Now we're going to look at least common denominators, because when fractions don't have the same denominator, you have to calculate what the lowest common denominator is and make sure both fractions have that same denominator. The simplest method to use here is to break down all the factors in each denominator and then list them above each other. I do it in rows. And this way it'll be easier to determine what the lowest common denominator is, because you're going to look at the factors that are unique and use each of those once. And then the common factors you use once, but only once, even though they're already included in both factors' denominators. And this way you can create a new denominator. So in our example, we have two fractions, 1 over 4r and r plus 3 over 10r squared. So to find the lowest common denominator, we are going to list the factors. So in 4r, we have 2 times 2 times r. And in 10r squared, it's 5 times 2 times r times r. So what you have in common here are the 2's and the r's. So you'll only use those once. So the lowest common denominator is going to be multiplication of all these factors. So you can use 5 times the 2 that is shared, times the 2 that is unique, times the r that is shared, times the r that is unique. So you end up with 20r squared. So each fraction has to have a denominator of 20r squared, and you'll have to multiply the numerator by whatever you have to multiply the denominator for to reach that 20r squared. Finding the lowest common denominator of binomials and trinomials. You have to factor all the binomials and trinomials to break them down into their simplest form, and then you can create the lowest common denominator using the same method we used before. I'll always use LCD for lowest common denominator, so you don't have to keep writing that down. This is also called the lowest common multiple. So in example 1, we want to find the lowest common multiple of x minus 3 squared and x squared minus x minus 6. In order to do that, you have to factor that trinomial, x squared minus x minus 6. And by looking at that, you know that that's x minus 3 times x plus 2. So you can see what they have in common is the x minus 3. So you're going to include that once in the lowest common multiple. And then the two factors that are unique are x minus 3 and x plus 2. So the resulting lowest common multiple is x minus 3 times x minus 3 times x plus 2. In example 2, c minus 2 times 2c plus 7. Neither one of those can be factored. They're in their lowest, simplest form already. So the lowest common multiple is actually the multiple of those two terms. So it's going to be c minus 2 times 2c plus 7. Now we're going to add fractions using lowest common denominators. So you want to look at the denominators, break them down into their fractions, determine what the lowest common denominator is. Because the denominator of the two fractions are different, 8x squared and 12x cubed, you have to see what they have in common and what's the lowest common denominator you can determine from that. Because you have an 8 and a 12, the lowest number that both of those can be factored into is 24. So you know you're going to use a 24, and then you have an x squared and an x cubed, so you need to have an x cubed term. So the LCD here is 24x cubed. So you're going to need to multiply both fractions by some version of 1 to get your denominator to be 24x cubed. So in the first case of 9 over 8x squared, you'll have to multiply that by 3x over 3x. And then the second term, that's 12x cubed, you'll multiply it by 2 over 2. And that's what I've done on the right-hand side of the fraction. When you multiply that out, it simplifies to 27x plus 10 divided by 24x cubed. To subtract, you're going to do something similar. We have 10 over 3x minus 7x over x plus 2. The LCD here, because both denominators are in its simplest form and they have nothing in common, is actually 3x times x plus 2. So you have to multiply the first fraction by x plus 2 over x plus 2 and the second fraction by 3x over 3x. When you multiply this out, you end up with 10x plus 20 minus 21x squared all over 3x times x plus 2. The only thing I would do differently in that numerator is change where the terms are because they're not in standard form right now. Put the x squared term first, followed by the x term by the 20, please. You can leave the bottom, the denominator factor though. Here's another subtraction problem. This one's a little bit harder. X plus 4 over x squared plus 3x minus 10 minus x minus 1 all over x squared plus 2x minus 8. You need to factor both denominators. And when you do, you see the first fraction is simplified to x plus 5 times x minus 2, where the second denominator is x plus 4 times x minus 2. Because they have that x minus 2 in common, you're only going to use that once in the lowest common denominator, but the other two unique factors you have to include. So you're going to include x plus 5 and x plus 4. So the LCD becomes what's written here in red, x plus 5 times x minus 2 times x plus 4. So you have to multiply each fraction by what it's missing, some version of 1. And don't forget to include the numerator and the denominator. You don't want to change the value of the fraction, just the value of the denominator. So in the first fraction, you can see the numerator becomes x plus 4 squared because we had to multiply by x plus 4. And in the second fraction, the numerator becomes x minus 1 times x plus 5 because we multiplied by x plus 5. When you multiply those out, your numerator becomes x squared plus 8x plus 16 minus the quantity of x squared plus 5x minus x minus 5. Now don't forget to apply that negative to everything in those parentheses or you're going to be really off. The denominator stays the same, x plus 5, x minus 2, x plus 4. You can simplify the numerator by combining all the like terms. You see the x squareds are going to drop out and you end up with 4x plus 21. Now we're going to look at using this in a word problem. We're looking at a boat traveling 24 kilometers upstream against the current and 24 kilometers downstream with the current. And you know that the speed of the current is 2 kilometers an hour. We don't know how fast the boat is traveling though in still water, and that's really key here. But you can still write an equation that gives the total travel time in hours as a function of the boat's average speed in water. So first write a verbal model. How are we going to set this up? Well, if you think about it, the total travel time for the boat is the time it takes to travel upstream plus the time it takes to travel downstream. And since distance equals rate times time, then time is distance divided by rate. Now, we know what the distance is. The distance is 24 kilometers both ways. But the rate we're not exactly sure of. We know it's the rate of the boat in still water, although we don't know what that is, so we're going to assign that R. But going upstream, when you're fighting against a current, you have to subtract the speed of the current. So the current is 2 kilometers. So the speed upstream becomes R minus 2, and the speed downstream is going to be R plus 2 because you're being aided by the current. So now it's easy to figure out. The total travel time is going to be 24 over R minus 2 plus 24 over R plus 2. But you can't add those together because they don't have the same denominator, right? So you have to find the lowest common denominator, which is R minus 2 times R plus 2, and multiply the numerators by what you need to. So in the first fraction, we're going to multiply by R plus 2, and the second fraction by R minus 2. When you simplify that, you end up with 48r. How does that happen? Because when you multiply the 24 times r in both the fractions, you get the 48r, but you have 24 times a plus 2 and 24 times a minus 2, so that those negate each other and those drop away. And then the denominator is r minus 2, r plus 2. So now, if you know the rate of the boat in still water, you can calculate how long this trip is going to take. We now have the function for the time. So what they ask you to do is calculate the time when you know the rate is 10 kilometers per hour in still water. And this is really simple now that you have the function. You just substitute the 10 for the r. So it becomes 480 over 8 times 12, or 480 divided by 96, which works out very easily to 5. And this is in hours because your rate was in kilometers per hour. So that's 5 hours that it would take the trip, round trip, upstream and downstream.